Good evening all. Welcome back to maths classes now. Here, especially in mathematics, in this 1 month session, just we are going to pick up some special areas weightage wise, where maximum weightage is given from the last few years as we have tested. So we pick those particular topics and chapter wise we give complete analysis, a short theory part to that, as well as shortcut techniques wherever required we discuss in these sessions. Among those, today I am picking one of the most important areas where students will be generally messed up with so many concepts involving, and also conceptually they feel little scary about that one. Such one topic I am picking here, which is vectors in continuation with 3D geometry as well. Here in vectors we can mainly divide this particular chapter into 3 parts. One is vector algebra, where in this part these problems will be tested on addition laws and vector concepts, even rotational concepts, as well as right-handed, left-handed systems. Some component based type of questions will be tested in this particular part, first part of this vectors, which is called vector algebra, and second part is mostly giving on mathematical calculations. It includes this vector and scalar products, or simply to say here products of vectors, vector products, maybe vector product or maybe scalar product, triple products, maybe vector triple product, scalar triple product, or multiple products. We focus how to do the problems based on these product related things. And coming to the third part of this vectors chapter, this is geometry of vectors. You know very well there is a lot of connection in between these vectors, 3D, even sometimes in complex numbers also. We cannot treat them as separate chapters. In fact, here we can give a clear coordination to these 3 chapters, 3-dimensional geometry as well as vectors and even complex numbers apart. That's why we have to focus especially on this geometry of vectors also. So for your convenience, here I am dividing this entire vectors into 3 different parts: vector algebra, various products related problems, then coming to geometry of vectors. These are 3 areas we are going to cover in this vectors chapter. Now mostly this second part, products of vectors, is a formula oriented. We derive some standard relations, standard results in scalar product, vector product, triple products, and we develop some standard formulae, and questions will be based on these formulae will be tested in general. Students will not get any confusion in most of the cases in solving the problems of this second related. Coming to third one, geometry of vectors also, because even sometimes we use coordinate geometry conversion techniques to solve the problems of this geometry of vectors. The problem arises to most of the students is this vector algebra. They will be messed up with too many concepts. If you open any IIT or mains or MSET related book, you can find out lot of synopsis points, some 50, 60, 70, even sometimes you can find out 80, 90 special points. So going through all these theory related points will give a lot of confusion in this chapter, even the technical terminology we use in this. That's why here my intention is to make this first part very clear. Just I don't want to give you too many points to confuse you again. Here entire vector algebra, more than 95% problems to solve. Here just we can focus on hardly 7 or 8 points in the synopsis part, and whatever the problem we are going to solve, entire problem will be solved by using these 7 or 8 points in the coming classes. Here in vector algebra, just because this is the first class, just I would like to reintroduce once again the very fundamental areas of this vector algebra in our shortcut orientation. Just I will pick up some few fundamentals of this chapter. Coming to these vectors, as everybody knows, here it is a special property comparing to scalars. Everybody know here it has not only magnitude and it is also having direction. So vector quantity has containing here magnitude as well as direction. But not only these two, everybody will say vector, in what way vector is different from scalar? Scalar has magnitude, but vector has magnitude as well as the direction. But here, apart from these two, the vector has a unique special property. Only for vectors it is available. Here, try to recollect that special property. If you are unable to recollect that special property, here I am using a word. Very frequently you can find out this word free vectors. What about these free vectors? Are they freely available everywhere here? Like in vegetable markets, it's not like that. Free vectors. Here, these free vectors, why vectors are called free vectors? Vector quantity has magnitude and direction, but it is freely roaming. Just wherever it wants, it can move. It has the freedom to move anywhere. It need not be stick down to a particular position. That's why vectors are freely moving. That is why try to recollect in most of the problems, in many problems. Here in geometry, suppose two lines are taken like this, we call them simply as parallel lines. And suppose in 3D, if it is a plane of whiteboard, and if a line is taken parallel to this, we call this line as parallel to this plane. But whereas coming to the vectors, you might be confused sometimes. A plane will be given and a vector somewhere is given parallel to this plane, and we call sometimes that this line is coplanar with this plane. How does it coplanar? The vector is here and the plane is here. It is parallel to that one. How can we say that that is coplanar? Simply because of this special property. It is freely moving in the space. We have the freedom to choose the location wherever we require for these vectors. That's why vectors are called free vectors. So according to our usage, according to our requirement, we can shift the vector wherever required without changing the direction and magnitude. That is why here we use this technical word free vectors. Once if that special unique property of vectors is confirmed, is clear, then here what is the advantage of that one? Here now vectors are freely moving. So if it is freely moving, we cannot do anything. That's why here what we do, for our convenience, we can relocate that vector without changing the direction and magnitude. Suppose this A bar is a free vector with certain magnitude given here. Now, if this vector is taken with an initial and terminal points, if it is taken as a vector with initial and terminal points defined to this, whenever we are giving this vector with initial and terminal points, then this vector will be called as a localized vector. Just we can give a name to this as localized vector. So every free vector can be expressed as a localized vector which is located in between an initial and a terminal point. So here it is very much clear that we can take the vectors as localized vectors with initial and terminal points. Now suppose somewhere if we imagine the point origin, then the vector obtained by joining origin with this can also be taken as this OA bar is defined as the position vector of A with respect to the origin. If we are taking the vector as AB bar, we can also call it as the position vector of B with respect to A. So here like this we can localize the given vectors. Here once the vectors are able to be localized, to solve many theorems or many new properties to develop, here the given vectors can be taken according to our choice. Here for example, A bar is here, B bar is here. Then to get the resultant of these two vectors by using addition laws, etc., here what we can do, simply this A bar can be taken as vector AB bar. So this terminal point wherever we have, from there we can take vector B bar. So the terminal vector of the first point has become the initial point of second vector. Like this, if we are relocalizing this one, so AB bar plus BC bar, the resultant we can find out by using triangular law or parallelogram law. That's why we have such an advantage only for vectors, and because of this special unique property of vectors only, we could able to find out many properties in very comfortable way than in scalars. So this is the advantage of these vectors. Now if this vector's unique property is clear here, now what are the main points to be noted, to be recollected at this moment to solve first part of this chapter? Here the first one is, here this addition laws, everybody try to recollect the addition laws we have here. First one we have triangular law, the same we can also rearrange as parallelogram law. If we have to add more than two vectors, we can use even the polygon law also. So like this we can take 2-3 addition laws here. These three laws are used for adding or subtracting the vectors in this first part here. So simple, it's very simple triangular law. A bar and B bar, if we are taking two vectors, take them as, so first vector AB bar is taken as A bar. From this terminal point we are taking the second one as B bar. These two vectors taken as without changing the direction and magnitude, that is very important. Without changing the direction and magnitude, let us take these directions like this. Now this third vector, third side AC bar will give you the resultant of these two vectors A bar plus B bar. This is simply called triangular law. Instead of taking them as adjacent sides of a triangle, if you are taking them as adjacent sides of a parallelogram, then this will become the diagonal. The diagonal will give us the resultant of these two here. So in simple way we can use this parallelogram law as well as triangular law to solve, to add given vectors. If we have more than two vectors, some 3 vectors, 4 vectors, 5 vectors like this, A bar, B bar, some C bar, okay, here like this D bar and E bar. Like this, suppose you have given 5 different vectors with different magnitudes. To get the resultant of all these, express all these vectors as adjacent sides of a polygon. Okay, that depends on the directions of this. The polygon may be a convex polygon or a concave polygon. It need not be a convex always. So simply first we take with A bar, AB, then in this direction with this magnitude we are going with B bar, then C bar is in this direction, we take this vector like this, then coming to D bar taken in this direction with this magnitude, this is D bar, and finally this is E bar. This is E, this is F if you are taking. So all the 5 vectors taken with same direction and same magnitude as given in this question here. Now we are getting this one. So we have started from A and we are ending at F. Now join A and F. This A, F bar will give you the resultant of all these 5 vectors, that is nothing but A bar plus B bar plus C bar plus D bar plus E bar. So this is called the polygon law. So here, depending on the given vectors number, we can choose triangular law, a parallelogram law, or a polygon law, etc. These are all used for getting the resultant of the vectors. So we are starting our main points with what? These laws, rules, addition rules for this vector algebra. Okay, now I am giving this as first point to be noted. Okay, now coming to second point. Coming to this second point, here using this addition laws, we can express any vector in terms of its base vectors. A very confusing other thing in vectors to a normal student is, just sometimes he will find a vector, as, just in the questions, a vector a bar is given as some 2i minus 3j plus 5k cap, ijk unit vectors along the xyz axis. In the very next problem, he will find another vector e bar as some 2a bar plus 3b bar minus 4c bar. Immediately student will get confusion, what are these a, b, c bars and I, j, k. Sometimes vector is represented like this, sometimes vector is represented like this. So here, to understand this confusion here, to avoid this confusion here, you must know how to represent a vector first of all. Generally, a vector can be expressed in terms of its base vectors, which are called base vectors. Okay, here to understand these two types here, first of all, the two types of methods how to express a vector must be clear at this fundamental stage. Here, generally, if three vectors taken, three vectors a bar, b bar, c bar, they may be mutually perpendicular or may not be. Here, any three non-coplanar vectors, I am repeating the word, any three non-coplanar vectors will form a system. And of course, the system will be different again, right-handed system, left-handed system. I will come to that immediately after completing this point. So here, before right-handed, left-handed systems and all those, because problematic formula oriented problems we can do very comfortably, but if the question is framed in vectors based on the concepts, you cannot move even an inch forward to solve that particular problem, because it is concept oriented. Unless you have the command on concepts, you cannot do anything in this vectors chapter. That is why just I want to make you very clear at this primary stage before entering into the problems. Here, there are two types of systems in which vectors can be expressed. So far, whatever we are observing here, first of all, if we are defining coordinate axis, x-axis, y-axis, z-axis, which are mutually perpendicular, every vector components are taken along with these three axes here. Just if a vector taken somewhere here, its components, suppose here if a vector is taken here somewhere, just we take its feet of perpendiculars on x-axis. Okay, here this is called x component. Similarly, y component, z component is defined. Now we define three unit vectors I, j, k. Suppose if their components are a1, a2, a3 on three axes respectively, then simply we can take this vector as a1 I cap plus a2 j cap plus a3 k cap. This cap represents a unit vector. I, j, k represents unit vectors along the coordinate axis in order. So adding these three resultant, like I said, Polygon's law, simply we will get back this original vector AB bar. So here we can express a vector in terms of base vectors I, j, k. So like in rectangular Cartesian system of geometry. So this can be taken as rectangular system, where we can also call it sometimes as unit orthonormal system. Each one is perpendicular to the other two directions. That's why it is called unit orthonormal system also we can call it. So we can express every vector in terms of I, j, k in unique way. We cannot get any other way simply it is unique always. So this is the first type of representation of a vector. Whereas coming to other one, the base vectors a bar, b bar and some c bar, these three non-coplanar vectors are not mutually perpendicular, it need not be. Okay, so like this we are selecting three non-coplanar oblique vectors, that's why we can take this as oblique system also. How to find out component of a vector on each vector we will discuss in the coming classes here, that is a separate one. So meanwhile just I am giving a brief idea. So we can express our given vector as some linear combination in terms of a bar, b bar, c bar. So our given vector also can be expressed as components along with a bar, b bar, c bar, some x a bar plus y b bar plus z c bar. So this is called oblique system. We can express a vector now onwards in two ways, either in IJK system or in oblique system. The base vectors a bar, b bar, c bar will be clearly mentioned in that particular concept or problem whatever we are going to discuss. So the two ways how to express a vector is clear. In this second point only, I am repeating, first point in my revision synopsis will be what? Addition loss. Don't go with too many synopsis concepts at this stage. Okay, hardly 7 or 8 points, not more than that. Every problem of this chapter can be solved by using this 7 or 8 points only. That is my intention to make you clear, all of you. Second one is here system. How to express a vector in various systems and what is the meaning of right-handed system, left-handed system, etc. and how to recognize whether the system is right-handed, left-handed systems. After making clear point on the definitions, how to solve the problems on these right-handed, left-handed systems in particular, and how to solve the problems of even rotation case, component case, etc. I will give you one or two previously tested problems on this second point related. Okay, here oblique system, whether the system is oblique system or a unit orthonormal system. What do you mean by right-handed system and left-handed system? To understand this right-handed and left-handed systems, here suppose two vectors are taken, a bar and b bar, c bar some third vector. Okay, just keep it aside temporarily, c bar. Now these two vectors a bar, b bar along with c bar is going to form a right-handed system or left-handed system to get in very simple way, not like the textbook definition way, just when we are observing from third vector, if the angle is less than 180, more than 180, that is not suitable to make you clear vision about this one. So for better understanding here, I am giving you the logic how to recognize them and how to do the problems on them also I will make you clear. Here first of all, a bar, b bar are two vectors taken in order. Now rotate a bar vector towards b bar vector. Okay, here this is the direction, it is rotated towards this vector. Now select one normal screw. Most of the cases in domestic purpose, whatever the screws we are using are called right-handed screws. Everybody knows if it is a right-handed screw, like this, if you are rotating clockwise, it will move forward, the tip will move forward. This type of screws are called right-handed screws. Now select one right-handed screw and start rotating in which direction now? In the direction along a bar is rotated towards b bar in this example. Here it is rotated in anti-clockwise direction. So I am rotating this right-handed screw in anti-clockwise direction. If I am rotating in anti-clockwise direction, as you know, if we rotate right side clockwise, it will move forward, it will penetrate through the wall. And if we are rotating it in anti-clockwise direction, it will come backward towards your direction. Okay, it will be released from the wall, generally screw. So here right-handed screw, if you are rotating in this direction, it is coming back, it is releasing from the wall, means the third vector, if it is taken in this direction where the tip is moving back, in this direction if you are taking the third vector, then that vector is moving along with the right-handed screw. Then we can say that A bar, B bar and C bar, all the three are forming a right-handed system, a right-handed system. And suppose if that third, if we interchange the vectors, suppose A bar, this is B bar. Now to move A bar towards B bar, to move towards this direction, we have to move in clockwise direction. When we are moving clockwise direction, the right-handed screw, it will penetrate through the board towards the other side, means it will move like this. So in this direction, if the third vector is taken, then that will be forming what? A right-handed system. If it is moving against to the direction of the tip of the right-handed screw, obviously they form a left-handed system. And obviously, and remember one more sensitive point here, right-handed system means it need not be moving perpendicular direction in this direction. All the vectors, it need not be normal, all the vectors here, if it is moving like this, it is coming this direction, all the vectors in this direction moving away from the board towards you, maybe parallelly, maybe in this direction or maybe in this direction, different directions, but only thing is it is moving away from the board towards you, towards your direction, then all these vectors are forming along with A bar and B bar in order. A bar, B bar and C bar will be forming a right-handed system. Okay, if it is like this, the third vector should be on the other side. All the vectors facing opposite direction, back side of this board will form what? Right-handed system. Opposite to that will give you obviously left-handed. If it is not right-handed, obviously they are forming a left-handed system. What in case if the third vector is also on this plane? Then they are clearly called coplanar vectors. If I am saying a system is forming, they are non-coplanar vectors. So we are clear about right-handed system, left-handed system and coplanar vectors. And one more technical point here, because we are being mathematics students, not only theory part will help us, its application is also important. If three vectors A bar, B bar, C bar given to you, find out its scalar triple product. Suppose if this scalar triple product is 0, then they are coplanar. We know it. It will come in the triple products. If it is positive, then simply we can form a right-handed system. If it is negative, it will form a left-handed system. Very simple mathematical technique to calculate whether they are forming right-handed or left-handed systems. Find out their scalar triple product, and depending on that sign, we will get whether they are positive, right-handed or left-handed or coplanar. Okay, so this is about the way of finding whether they are forming right-handed or left-handed, because physically we cannot find out easily three vectors in the space if they are given. We can't analyze easily, we cannot visualize them in our mind that whether they are forming right-handed or left-handed systems. Okay, how to check if three vectors are given, whether they are forming right-handed, left-handed also clear now. Now the next thing is, especially when the problems are given in the exams like JEE mains or even advanced, or even sometimes in MSET also, problems won't be given like this on these definitions and all those. Just problems will be given on conceptual techniques. Okay, just for example, let me say the components of a vector. Just I am giving a simple example. Practically what problem arises, even though you know the concept, even though you understood the meaning of these, we are unable to solve the problem sometimes. Simple example previously tested long back, I am giving that problem here. Here A bar is a vector whose components or A1, A2, A3 in a left-handed system, maybe right-handed or left-handed, that is our choice. Clearly my choice, I am giving this one. A bar is a vector whose components in this left-handed system are A1, A2, A3. Now, here this xy plane taking z-axis as axis of rotation, here taking z-axis as axis of rotation, xy plane is rotated through how many degrees? 90 degrees in clockwise or anti-clockwise, depends on the choice, clockwise direction. Then in new system, what are the components of this vector? Vector is remaining as it is, vector is not changed, its direction as well as magnitude, but here the entire system is rotated. How it is rotated? XY plane is rotated along the z axis as axis of rotation in clockwise 90 degrees. Then what will be the components of this vector in new system? A question is given like this, then suddenly students will come with a blank mind. You know the concept, you know the definition, you know everything, and technically you can find out whether it is right-handed or left-handed, but what to do in this case? We cannot use any formula to find out the solution to this type of problems coming in competitive exams. There here, for this type of problems to solve, whether it is clockwise, anti-clockwise, whether it is right-handed or left-handed, or any other alterations have been done to this type of problems to solve, I am giving a simple technique to you. What is that here? Whenever we are getting right-handed and left-handed systems related problems here, definitely you are writing exam means you will be sitting somewhere in a room. If you are sitting in a room, definitely you have two opposite corners to you. Okay, so here select your right side opposite corner to your view. I am telling this one, this is the right side corner. If you imagine, you are finding here some horizontal this line, and this is one more corner line, and here vertical line we have. Okay, so here you will be finding, suppose take it as x-axis, this vertical one y-axis, and this side wall corner line is taken as z-axis. Okay, right side one. If a problem is given on left-handed system, you choose this right side corner. If the problem is given on left-handed, why it is this one? This is forming what type of system? Try to understand now. This is x-axis, this is y-axis, this is z-axis. In order, x-axis is rotating towards y-axis in what direction? Clockwise direction. Clockwise direction. If you are rotating screw in clockwise direction, it is moving forward. It is penetrating through the board to other side. Tip is moving in this direction, but this wall is in this direction, starting from origin. Is it against to the direction of the tip or not? That's why this is called left-handed system. So there is no other best example to visualize yourself three-dimensional in your mind in classroom for these left-handed systems. Whenever a problem comes on left-handed systems, immediately start comparison with your right-handed corner opposite to you. And obviously, if it is a right-handed system, if you want, you take left side corner. How do you get left side corner? This vertical corner y, x-axis, this is z-axis. X-axis rotated towards y-axis in anti-clockwise direction. If you are rotating it anti-clockwise direction, here the tip is moving. Just observe, take a right-handed screw and imagine how you are rotating now. You are rotating in this anti-clockwise. If you are rotating in anti-clockwise, it is supposed to move backward, your direction. So tip is moving in this direction, where this z-axis also taken in the same direction parallel to that. That means it is moving along with the same tip of the right-handed screw. That is why it is called a right-handed system. So the best way of visualizing to solve this type of rotation problems in your without any formula is what? It is everything in front of you. If left-handed system is required, just start comparing with right side corner, and if you want a right-handed system, take the left-handed corner. Very simple, opposite to this, not behind you or any other case. Wherever you are sitting, sit as it is. Otherwise, you won't be allowed to move here and there in exams. That's why I am telling you very strictly. So, if you are comparing, there is no objection from anyone. Now, in the present problem, just let us take this example, how easy to solve this problem. Here, I am giving the condition as the vector A bar has its components A1, A2, A3 earlier before the rotation, and the system is given as left-handed system, if I remember well, left-handed system. Now, XY plane is rotated, XY plane is rotated through 90 degrees, in which direction? Clockwise I have mentioned. Then what will be the new components you are getting after the rotation is the question. We cannot use any formula for this. Now, I used left-handed system, so immediately we compare with what? Right-handed corner. Okay, right-handed corner. So, this parallel corner is, this corner is z-axis. Along z-axis, xy plane is rotated. Towards what direction? Clockwise direction. Okay, now. So, actually here, this is x-axis. Here somewhere we have x component. This length is a1. This length is a2 y component. This length is a3. a1, a2, a3, these are the components defined earlier. After rotation, observe the rotation given here. We are rotating xy plane through 90 degrees clockwise. Clockwise means we are rotating in this direction. 90 degrees, if you rotate x-axis, it will come to y position. Is it point clear now? So, new x-axis will come here. This will be new x-axis. Okay. Already here vector is remaining as it is. Vector, there is no change. Now, already this length component has been given as a2. Now, this a2 will become the component of this new x-axis. So, new x component is a2. Right, that is clear. Now, x-axis comes to here. When you are rotating 90 degrees, this y-axis will go further 90 degrees like this. So, new y-axis will go like this. Here will become. This is new y-axis. But already this is x-axis, previous x-axis. The only difference is it is taken in opposite direction. So, this new y-axis is in the direction of negative x-axis. Okay. So, here already this is new y-axis. Now, what will be its component will come. So, if it is y-axis, this will become new negative y-axis. On negative y-axis, what is this length of component already given? A1 is given. So, component length is A1 in the direction of negative y-axis. That is why what will be new component will come here for this vector minus A1. And one can imagine comfortably we are not disturbing z-axis. Z-axis is taken as the axis of rotation. So, it will remain as it is, no change in the z component. That is all. For this, after all, you require what? You know the concept, you know the definitions, you know how to find. But technically, if a problem is constructed sensitively on such rotation in left-handed system or right-handed or anti-clockwise or clockwise, so many permutations, combinations are there to construct a question on this to make you a twist. After all, you are writing the competitive exam where lakhs of students are competing, where here they are not testing your subject depth every time. Most of the times they try to construct the question paper on elimination techniques. Most of the students should be eliminated from the competition in such a way to test. If it is too typical question framed, if the question framed is too typical, we cannot find out enough candidates for the counseling even. If it is too easy, hardly with 1 or 2 marks difference all the seats will be filled up. It is too injustice to many other students. That is why paper should be in a balancing way. At the same time, it should test the root levels very sensitively. Like that, they will test such type of questions on this. I hope all of you now you can clearly understand the way how can solve the problems of left-handed systems, right-handed systems, their rotation levels, etc. Here that's all. This is about the second point I want to stress at this moment. I told you, I am repeating once again, I am not giving excess points, too many points. I told you in synopsis, if you open any book for mains or MCET or IIT advanced, you will find hundreds of synopsis points, 70, 80, 100 like this. So forget about all this, just focus on 7 or 8 points which I am going to give you. Okay, so here, just because this is the first day, here just I want to go a little bit slowly with conceptual techniques and all those. Okay, here first today we have covered 2 important points on which this entire vector algebra is starting now. Okay, so this is vector loss and how to represent a vector in 2 types of systems, right-handed, left-handed systems, and tomorrow will let me complete the rest of the 5 or 6 points, and based on 6 or 7 problems, how to solve all the previously tested problems so far, whether it is IIT advanced or mains or MCET or BITSAT, whatever it may be, irrespective of the level of the question paper, how to solve comfortably by using these 6-7 synopsis points we are going to focus in the coming classes. Okay, I hope all of you are enjoying this session. So will be continued tomorrow as well as per the regular schedule. Okay, thank you all of you. Thank you once again. See you tomorrow.
V3 News